Okay, we have learned about vibration. In the vibration, we have identified the amplitude, the frequency, and the period. Now we are going to talk about the wave. So what is wave? Wave is a form of vibrational energy that travels through a medium. The example here, we have the rope. Okay, when it moves, okay, it make a wave. And then this one, the spring or the slinky when it move, okay, it make a wave. This one, the transfer wave or longitudinal wave or the ocean wave, that the vibrational energy that travel through the medium. So remember the medium. So we have three medium, right? Gas, solid, liquid. So it means the wave can travel through the gas, solid, and liquid. For example, the wave that travel through the gas is sound wave. The sound wave can travel through the gas, and the solid is the earthquake. Okay, and then the liquid is this one. The ocean wave is the example of the wave that travel through the liquid. Okay, here look, because the sound can travel through the air, so how does sound get to our ear? So for the example, this picture, the vibration cone, it will produce sound and then vibrate the particle airs in a sound wave, and then it will travel through our ear, okay, here, so we can hear the sound. So the particles in the air are made to vibrate backward and forward in a time with the vibrating object. So this, when the source of the vibration vibrate, it make the particle around it vibrate too. Okay, the particle air, so it will travels through our ears, so we can hear the sound. Okay. And then the speed of the sound wave in the air is around 343 meters per second. And then the substance that sound move through is called medium. Okay, the substance we have three before: solid, liquid, and gas. The type of wave here, so we have two type, okay, according their medium and according their direction. The medium and the direction. Okay, first the medium. So in this type we classify into mechanical wave and electromagnetic wave. Mechanical wave, the wave that need medium to travel it. Okay, and then the second we have the electromagnetic wave. It do not require a medium to travel it. Mechanical wave, for example, the rope wave, okay, the water wave, the sound wave, the slinky, that need medium, the medium, solid, liquid, gas. And then the electromagnetic wave do not require a medium. For the example, the light, okay, the microwave, and then the radiation, okay, that electromagnetic wave that doesn't need medium to travel it. And then the other type of wave according the direction, so we have two, the transverse wave, Okay, so the transfer wave is a wave whose particle vibrate perpendicularly to the direction the wave is traveling. This is the transverse wave, perpendicular, and then the second type according to direction is the longitudinal wave, the wave whose particle vibrate parallel to the direction of wave traveling. This is the example of the longitudinal wave. The sound wave is the longitudinal wave here. The transfer wave is the electromagnetic wave. Now, the same with the vibration properties. Okay, the wave has the properties too. It has frequency, of course. It has period. It has the amplitude. Okay, look at this picture. Okay, the amplitude is the maximum displacement from the equilibrium position. So here, this is the equilibrium position, right? The maximum displacement, this one is the maximum displacement. So it's called the amplitude. Okay, and then the frequency. The frequency is the number of wave over time. The period is the time need to make a one wave. Here, the equation same with the vibration, frequency n over t, period t over n, the number of wave. And then the other properties, we have the one with the wavelength. The wavelength is the distance between two adjacent similar points of a wave, such as from crest to crest or from true to true. This is for the example, this picture. Okay, the distance between crest to crest is wavelength, or true to true it's wavelength. Okay, so or we can say this one. Okay, the distance from A, B and C, this one is one wavelength. Okay, and then the speed of the wave is the distance traveled by the wave in the unit time. Okay, this one, the speed of the wave, lambda time f. Remember, it has relation, right, between f and t. T equal 1 over frequency, or frequency equal 1 over period. This and this, or we can show here, this is the v, this is the lambda, and this is the frequency. Or if we want to use the period, this one, the period one, this is the v, this is the lambda, and this is the period. Okay, so how we can find how many waves that form in certain time? Here, for example, okay, so one wave is, it consists one crest and one true. So the distance, this one until this one, this is one wave. So how many wave from this picture? Okay, let's identify. Okay, the second wave is this one. This is the second wave. Okay, the first, second, and then how about the third? Okay, the third, this one, the third wave. So this picture consists a three wave. Okay, and then how the distance only until this one. So how many wave here? It's half wave. Okay, this one too, half wave. And then the other properties of wave can be reflected. So at fixed boundary, waves are reflected and inverted. Reflected and inverted. Inverted is mean in the opposite position. Okay, this one for the example, this the incident pulse, this picture, and then back again here, reflected pulse in these opposite directions, and then this one, okay, reflected. This is up, this is down. So a wave patterns that result when two waves of the same frequency, wavelength, and amplitude travel in opposite direction and interference, it's called standing wave. So it's called standing wave. The example here. Okay, next, to check your understanding about a wave, the properties of wave, this is the question to pay attention to the figure of the transfer wave below. Calculate the frequency, period, amplitude, the wavelength, and the speed of the wave. The displacement, remember displacement is, the amplitude is the maximum displacement from the equilibrium position. Equilibrium position is the horizontal line, this one, so it means the higher of the peak or the lower of the, this one, throw, the crest and the throw. And then the frequency is the number of the wave per second. And then the period, time needed to make one wave. And then the wavelength, the distance between two successive points. So the two points in the same phase. The speed of wave, okay, the speed of wave, speed equal frequency time wavelength, or the wavelength divided by the period. Send your answer.